Greetings. This is Anmay Kalim, and I will be showing to you how to graph polynomial functions. There are 6 steps in graphing polynomial functions. First is to determine the graph's behavior. We can determine the graph's behavior using the leading coefficient test. In the leading coefficient test, there are 4 types of graph behaviors. The first one is if the degree of the function is odd and the leading coefficient is positive, then the graph falls to the left and rises to the right. If the degree is odd and the leading coefficient is negative, then the graph rises to the left and falls to the right. If the degree of the polynomial function is even and the leading coefficient is positive, then the graph rises to both sides. If the degree is even and the leading coefficient is negative, then the graph falls to both sides. Second step is to find the zeros of the function. Third is to find the y-intercept where we let x to be 0. The fourth is to find the number of maximum turning points. Turning points is where the graph changes its direction. So to get this, we use n-1, where n is the degree of the function. Fifth step is to find the extra points. The extra points are the values we substitute to x, where we get y, and then use these points to know where the graph is headed to. The values for x here, we use the ones that are between the values that we get from steps 2 and steps 3. For 6, we graph the function. For example, we are tasked to graph the function f of x equals x cubed plus 3x squared minus x minus 3. So, using the first step, we will determine the behavior of the graph. As you can see, the degree here is odd. And the leading coefficient, which is positive 1, is positive. Therefore, we know that our end graph will fall to the left and rise to the right. Second step is to determine the zeros or find the zeros of the function. So, we will equate the function into 0. And solving it, we will get Okay, this is from factoring or getting x squared. Then we get x squared times x plus 3 minus 1 by getting negative 1 times x plus 3. And factoring x plus 3, we get x plus 3 times x squared minus 1 equals 0. So, getting this one, we have now the zeros. X is equal to negative 3 from this one. And x is equal to positive 1 for this. And since this is squared, then we get also the negative 1. Third step is to get the y-intercept. And in y-intercept, we let x as 0. So, since our function is x cubed plus 3x squared minus x minus 3, this is our f of x. So, we let x to be 0, so f of 0 equals 0 cubed plus 3 times 0 squared minus 0 minus 3. And solving this one, we get negative 3. So our y-intercept is negative 3, so our point will be 0, negative 3. Next step is to find the maximum number of turning points, and we have n-1. Since our n here is the degree of the function, which is 3, so n-1 equals 3 minus 1, which is just equal to 2. So there are 2, the maximum number for turning points is 2. Last step is to find extra points. And since we got negative 3, positive 1, negative 1, and for y-intercept which is negative 3, then we will choose the number that is between those values. And we have that value as positive, rather negative 2. We have negative 2. So we use, if our x here is negative 2, then we need to determine our f of x. Okay, so solving f of negative 2, we have negative 2 from our function cube plus 3 times negative 2 squared minus negative 2 minus 3. And solving this, we get positive 3. Therefore, our new point is negative 2 and positive 3. This is now our new point. So the last step is to graph our function. Since we have our zeros, negative 3, positive 1, and negative 1, so we now have these points on the graph. And we have our x-intercept, or y-intercept rather, as negative 3. So we have this one. And for our last point, for our fifth step, we obtain the point negative 2 and positive 3. So negative 2, positive 3 here. And since we know the behavior of our graph must fall to the left and rise to the right, therefore our graph will look like this, connecting the points. So this is now how our function, the graph of our function looks like. Another example is to graph the function x to the fourth minus 2x cubed minus 3x squared. So our first step is to determine the behavior of our graph. Since our degree is even and the leading coefficient is still positive, so the graph rises on both sides. Okay, so next step is to determine the zeros of the function. So we now equate our function to 0. Okay, so factoring, we get and since we can factor this one, we have x squared times x minus 3 and x plus 1 equals 0. And we now obtain the zeros of the function x equals 0, which is of multiplicity multiplicity 2. We have 0 as multiplicity 2 because we have x squared. And x squared has 0 and 0. Okay? X squared equals 0, and getting the roots, we have 0. If we know that the multiplicity of 1 0 is 2, then we have the idea that the graph touches 0 once and then turns around or turns to the other side. Okay? So the next, we have the other 0 as x is equal to 3 and x is equal to negative 1. Third step is to find the y-intercept of the function. So we let x to be 0. So our f of 0 is now 0 to the fourth minus 2 times 0 cubed minus 3 times 0 squared. And solving this, we get 0. Okay? So our y-intercept is 0, 0, which is just the origin. Okay, so this is our third step. And our fourth step is to determine the number of maximum turning points. So we have n minus 1, where n is the degree of the function, which is 4. 4 minus 1 is equal to 3. Meaning, there are maximum of 3 turning points in this function. Okay, so the next step is to find other extra points. Since we have 0, 3, negative 1, and 0 as the results for our steps 2 and 3, we now choose the values for x that are between these numbers. So starting with the lowest value, which is negative 1, the next is 0. So the number between them, we will choose negative 0.5. Okay, so from 0 to positive 3, we have 1 and as well as 2. Okay, so replacing the x, substituting it by negative 0.5, we get negative 0.437. Okay, so we now have the point, negative 0.5 and negative 4.437. Okay, so next, substituting 1 to the function, we get negative 4. So our point is positive 1, negative 4. And for the last one, we have 2. The value we have is negative 12. So we have the point 2, negative 12. For our last step, we will now graph our function. Since we have the zeros, 0, positive 3, and negative 1 for our x-axis, and then we have our y-intercept, which is 0, which is just the origin, and then we have our new points, negative 5 and negative 4.437, which we'll get here between negative 1 and 0. And we also have positive 1 and negative 4, which is just around here. Okay, and we also have positive 2 and negative 12, which is around here. Okay, and since we know that our graph is the type 3 graph where both sides rises upward, so we will now connect our points. So our graph will look like this. Okay, so that would be all. This is how to graph polynomial functions. And again, this is Miss Lim, and thank you for watching.